Dear class 10 students, welcome back to our YouTube channel me.u. Chapter 1 Real Numbers continues. In this video, the exercise 1.3 will be solved completely with explanation. Please keep watching. Okay, let's start with the question number 1, exercise 1.3. In the last video, we studied how to show that root 2 is irrational. We will show root 5 also in the same way. So first we'll assume root 5 is rational. Okay, since root 5 is rational, so it can be written as, therefore root 5 can be expressed as root 5 equals a by b, where a and b are coprime integers. A and b are coprime integers. So you know what are coprime integers. In the last video I explained what is meant by coprime integers. That means there is no common factors between a and b not equal to 0. So the denominator should not be equal to 0 for any fraction because it is not defined. Now we have root 5 equals a by b. Squaring on both sides. Squaring both sides, we will get 5 root 5 square equals 5. 5 equals a square by b square. Now multiplying both sides by b square, we will get 5 b square equals a square. Next, a square equals 5b square, or 5b square equals a square means 5 is a factor of a square, implies 5 is a factor of a square. So we had a theorem in the previous section that if 5 is a factor of a square, then 5 is a factor of a. So from using the theorem we can write 5 is a factor of a. That means a is a multiple of 5. So a can be written as 5m, right? Because a is a multiple of 5. 5 is a factor of a means a is a multiple of 5 for some integer m. Squaring again. So we'll get a square equals 25m square. Now we know that here a square, and already we have one a square here. In both cases, so you can equate a square, right? Here a square is equal to 5b square and 5b square, and here a square is equal to 25m square. That means 5b square equals 25m square. Dividing both sides by 5, you will get b square is equal to 5m square. Means b square is a multiple of 5, or 5 is a factor of b. 5 is a factor of b square, means 5 is a factor of b. So this is equation number 2 and this is equation number 1, statement number 1. So from 1 and 2, what you will understand? 5 is a factor of both a and b, implies 5 is a factor of both a and b, right? That means 5 is a common factor, which contradicts our first statement that a and b are coprime. It contradicts the statement that a and b are coprime. So our assumption is wrong. The assumption is wrong. Assumption is wrong. Then what is the conclusion? Root 5 is irrational, implies root 5 is irrational. Clear? So we'll go to the next question. Now let's see The second question, prove that 3 plus root 5 is irrational. In these type of questions, when it comes for examination, mostly the question will be like this. Given that root 5 is irrational, prove that 3 plus root 5 is irrational. That means already root 5, root 3, root 2 irrational or irrational will be given in the question. But here it is that is not given, even though we'll assume that root 5 is irrational and will solve the problem. So we'll start. Here in this case also we are using the contrary method. Assume 3 plus root 5 is rational number. Assume 3 plus root 5 is rational. Now if 3 plus root 5 is rational, so we can express 3 plus root 5 as a p by q form or a by b form. So implies 3 plus root 5 equals a by b, comma, where a and b are coprime, where a and b are coprime and b not equal to 0. So for every fraction we should state that the denominator is not equal to 0. Now, so it implies taking subtracting 3 on both sides, so you will get root 5 equals a minus b minus 3. Simplifying the right side, you will get root 5 equals a minus 3b divided by b. Now we can analyze the LHS and RHS. So this is the LHS and this is the RHS. So LHS, we know, we started with this concept, that the fact that root 5 is irrational. So LHS means that is root 5 that is irrational, right? Now what about the RHS? Right hand side you can see that A, B and 3. So these are the three numbers included in the RHS. So A is an integer, 3 is an integer, B is another integer. Any operation on integers will result in a rational number only, because integers are rational numbers, and any operation on rational number will result on rational number only. That means the operation means basic for operation: addition, multiplication, division, subtraction. So with the condition the denominator is not equal to 0. So here A minus RHS is a minus 3b divided by b is rational. That means an irrational number is equal to a rational number. From LHS is equal to RHS, we got LHS and RHS are equal, right? It is an equation. That means LHS is an irrational number and RHS is a rational number, which is a contradiction, that it cannot happen. Irrational number and rational numbers are entirely different set of numbers, so they cannot be equal. That means our assumption is wrong. So assumption is wrong. Assumption is wrong. Then what is the correct statement? 3 plus root 5 is irrational. Clear? In question number 3, there are 3 sub questions. The first sub question is, prove that 1 by root 2 is irrational. Like in previous questions, here also we will start with the contrary, that 1 by root 2 is rational. So we'll start with assume 1 by root 2 is rational. Okay. Now, if it is rational, we can express this in the form of a by b. Every rational numbers can be expressed in the form of a by b, where a and b are integers, coprime integers. So implies 1 by root 2 equals a by b, where a and b are coprime integers. Coprime integers, b not equal to 0. The denominator should not be 0 for any fraction. Now cross multiplying, you will get b. So this b will be multiplied here and root 2 will be multiplied here, so we'll get b times 1 equals a times root 2. Dividing a on both sides, we'll get b by a equals root 2. Now we'll take the LHS and RHS. So you know that LHS, what is LHS here? LHS is b by a, an integer over another integer, is always a rational number, so it is rational. But root 2 is irrational, is an irrational. An irrational number cannot be equal to a rational number, so it is a contradiction. So we got a contradictory statement. That means b by a equals root 5, which cannot happen. That means our assumption is wrong. So implies 1 by root 2 is irrational. Done. Now second sub question, that is B of question number 3. Prove that 7 root 5 is irrational. In the same way, we will start to the contrary, that 7 root 5 is rational. Assume that 7 root 5 is rational. If 7 root 5 is rational, so 7 root 5 can be expressed as it is equal to a by b for some co-prime integers a and b, where a and b are co-prime integers. B not equal to 0. Okay, the denominator should not be 0 for any fraction. Now we'll divide both sides by 7, so we'll get root 5 equals a divided by 7b. Now we'll analyze the LHS and RHS of this equation. So LHS equals root 5, which is an irrational number. And we analyze the RHS. So RHS is a divided by 7b. That means a is an integer, 7 is integer, b is another integer. And integer divided by another integer is always a rational number. So it is rational number. That means this equation says that an irrational number is equal to a rational number, which is impossible. That means it is a contradictory statement, right? So why we got the contradictory statement? Because our assumption is wrong. Write the correct statement that 7 implies 7 root 5 is irrational. Done. It's very simple, right? Now the last question of this exercise 1.3, question number 3c. Prove that 6 plus root 2 is irrational. Like the previous questions, to the contrary, we'll assume 6 plus root 2 is rational. Assume 6 plus root 2 is rational. Implies 6 plus root 2 can be written as a by b, where a and b are co-prime integers and b not equal to 0, because for any fraction denominator should not be equal to 0 because it is not defined. Now subtracting 6 on both sides, so we'll get root 2 equals a by b minus 6, implies root 2 equals a minus 6b divided by b. Now we'll analyze LHS and RHS. What is the LHS of this equation? LHS equals root 2, which is an irrational number. Right? We know that root 2 is an irrational number. And RHS, what is RHS? RHS is a minus 6b divided by b. A is an integer, 6 is an integer, b is another integer, and the operations between the integers results always in rational number. So you won't get any irrational number by operating integers. So it is an irrational number. Rational number. That means this equation number 1, is a contradictory statement. That means an irrational number is equal to a rational number, which cannot happen. So there is a contradiction in the statement. Why the contradiction? Because our assumption is wrong. What is our assumption? 6 plus root 2 is rational. So the correct statement is 6 plus root 2 is irrational. Done. That's all for this exercise. So we'll solve the next exercise in the next video. Thank you for watching the video. Hope you understood the concepts. Continue watching the next video. Thank you.